Hi there, this is a quick video to show how to measure residual magnetism on rotor shafts, and hopefully you will join our survey to look at what is the prevalence of this residual magnetism on rotors in the industry. The instrument I'll be using to do the residual shaft magnetism measurement is called a Gauss meter or Tesla meter. This is commercially available. This is just one of the units. One thing I need to check this one specifically has got a radial probe, and it shows you here for a radial probe this is how you do the measurements. See, this way you can't do it this way. If you have an actual probe, you need to do your measurement like this. Now this specific unit, I'm going to turn it on. It's currently set at Tesla, and it's got a setting there that I will change it to Gauss, and that's how I will take my measurements in Gauss. So remember, you need to check what kind of sensor you have, because that will determine how you do the measurement on the shaft. So let's go and do some shaft measurements. Here's a rotor that I want to measure the residual shaft magnetism on, but first I want to fill in my survey so that I know what it is. I'm going to fill in the job number, the industry. Now this one I look up, I know it's chemical, so I'm going to mark petrochemical. And if the sort of catch-all is industry, that's if you don't know what it is. I looked up this one, like I said, is chemical. Then I want to mark, is it a motor or generator? Is it an AC induction machine? Yes, that's what it is. Or is it a wound AC induction machine, a DC machine, or synchronous? Then size-wise, I know this one is less than 1,000 horsepower. And then I want to record my readings, and if there's a reading larger than 2 Gauss, we'll make a note, take some photographs, and see if can I see a failure or is there no failure, and then hopefully know a little bit more about the machine. So let's go ahead and look at the machine and take some measurements. Okay, so now on my rotor, this is the drive inside. I've got my instrument and I want to take the measurement, make sure it's on 0, and then remember, because it's a radial probe, I want to go perpendicular to my measurement. Oh, and look at that, that is more than 2 Gauss. I can move it around slowly and see it will take some time to settle, and you'll see over the length of the shaft it does change. That's quite normal. See here, somewhere in the middle, the reading was about 0.36. Clearly it is more than 2. So I want to take a photograph of that and record it. So it's about 3 Gauss. I'm going to move to the opposite drive end. Repeat the same process again. It's a radial probe. Put it on the shaft. Oh, look at that. You see, it takes a little bit of time for it to settle. That's normal. Yeah, 2.3, 2.4. 0.9, 3.1. Okay, so now I know this rotor has got a problem with high residual magnetism. I want to take some photographs of the measurements. And then of the rotor itself. Now this specific one, I can clearly see that we've had a failure of the end ring. Now that is useful information when we do the combination of all the results together. We will do analysis and see which kind of failures correlate to rotors with problems. And now to complete this survey, I filled in all the data. It's a job number for my reference. It's a chemical company. It's a motor, it's an AC induction. It is less than 1,000 horsepower, and the measurements on the drive end is 3 and 2.9 on the opposite or non-drive end. They fail, and I have a drive end ring failure. So you're welcome to contact me for this form. I can send you a template and you can submit your data to me. Obviously we don't just measure rotors with high magnetism, but we want to measure all rotors so we can get a large population of results to get statistically significant values and understand better of the prevalence of residual magnetism on rotor shafts. Thank you for joining this survey, and please send me your results.